Okay, so in 5.3, we're going to learn a lot of properties of logarithms. And so you want to take your time, you want to memorize what you need to memorize, and you want to try to just use common sense to sort of analyze what's happening. Now, before I start the slides, I want to give you an example problem here. Like, let's say I give you log base 2 of 8, and I ask you to solve that. You know, right? We always try to go to exponential before we even try to go to our calculators, right? If I rewrite this as 2 to the x equals 8, it's really obvious that x is 3, okay? Now, if you go to your calculator and you try to type in, the log of 8, right? You try to do that on your calculator, you're going to get an answer that is not equal to 3. And that's where you're going to realize that the log button on your calculator is set to default to base 10. Okay, and so our base here is 2. And so for most of you, you can't use your calculators to do that. So there is a lesson, and in the next slide it goes over it, but there's a lesson on how to convert or change your base from log base 2 to, for example, log base 10 or log base e, which is natural log. Okay, and so how we change our base and how we're going to get an answer of 3 is if you go to your calculator and you do this change of base thing, which basically what you're going to do is you're going to do either log base 10 of 8 over log base 10 of 2. So it's log base 10 of this value over log base 10 of that, okay? And when you do it and you go to your calculator, you do the two things, you're going to get the answer of 3. The other way to do it is using natural log, log base e of 8 over log base e of 2. Or you could do ln of 8 over ln of 2. Your calculator has both common log buttons and it has natural log buttons. And again, this is going to give you 3. So a lot of times when you have a problem, if you can't solve it using exponential, I would always try to use exponents first. It's just easier and just quicker. But if not, then you can go to your calculator and solve them. But prior to that, you have to change the base. So this slide is just trying to tell you that when you have this scenario, you can change the base a to another base, okay, by doing, and again, I would do log base 10 of x over log base 10 of a, or log base, or natural log of x over natural log of a. So if I have an actual problem, I can do log base 10 of 23 over log base 10 of 3, or natural log of 23 over the natural log of 3. And so again, like something like this, I would have to use this form, because if I did this as a problem and I said log base 3 of 23 equals x, it's 3 to the x power equals 23. Well, I don't know what x would be to give me 3 to that x equaling 23. So this is the time when you have to know how to convert it. If it was something simpler, like for example, log base 3 of 27, I wouldn't need to do that because I know that 3 to the x is 27, so x is 3, right? And again, let me show you. 3 to the x equals 27 is 3 cubed, so I cancel my bases and x is 3. So again, whenever I can use exponents, I'm going to. But when I can't, I have to know these alternatives, okay? And so I have to know how to be able to change my base. So in this slide, you're going to have some of these problems, right? So we can rewrite it as a ratio of a common or natural log, and then I want to evaluate it and round my answer to 4 decimal places. So let's get to that. So again here, obviously, I'm always kind of thinking, can I do this just in exponential? 4 to the x is 25. Yeah, no, I can't do it, right? So I do have to do the way they're telling me. So rewrite it as a ratio. Well, I can either do log base 10, I don't have to write the 10, of 25 over log base 10 of 4, or I can write it as ln 25 over ln of 4. Either way, I'm going to go to my calculator and I'm going to have to do these things, right? So I'm going to come to my calculator and I'm going to first identify what is the common log of 25. So I just 25, the common log, it's 1.39794 over, and then what is the common log of 4? It's 0.60205 or whatever. And then I'm going to divide. Now, you could do the rounded. I prefer to insert it into my calculator and never really write it out. In other words, find the log of 25, divide that by, I do parentheses, the log of 4. And I know that that's approximately equal to 2 point, and it wants it to 4 decimal places, so 2.3219. And that would be my answer for that first problem. And if I did natural log, I just want you to see that that also works, and I want you to try that on your calculator. The natural log of 25 is 3.21888. The natural log of 4 is 1.38629. And when I divide that, again, I'll get natural log divided by parentheses, natural log of 4 equals, and it's approximately 2.3219. Same answer, okay? Again, you choose which one you want to use. I like to use natural log because it's less letters to write. I know that's weird, but that's what I do. And again, that's how you solve this change of base. So we'll do the next one. Let me just erase this and move it out of the way, right? And let's do the one on the right. So again, if I try to solve it at first, 2 to the x equals 12. I don't know what x is, so unfortunately, I do have to do the change of base. So I'll do something like ln 12 over ln 2, and I'm going to get my approximate answer. So the natural log of 12 is 2.48. If I divide that by the natural log of 2, which is 0.693 something, I'm going to get 3.58496. So that's going to round to 3.585. And that's my approximate answer, okay? And so again, make sure that you can solve it and get those solutions. Now we go on to properties of logs. And again, we want to learn these properties because it helps us to manipulate these situations. It helps us to make things solve, and you're going to see what I mean. So for example, if I have a log with a base, right, log base A of u times v, I could separate this into two things. I can make it log base A of u, one factor, plus log base A of v, the second factor. And so I can expand this multiplication to an addition problem. So think about how you might be able to use that. Let's say you have log base 2 of, whatever. We have 24, okay? Well, that also is the same as saying, I can think of 24 as, for example, 12 times 2, right? And I could make that log base 2 of 12 plus log base 2 of 2. And sometimes that helps me because notice when I do log base 2 of 2, I know this equals 1. So all of a sudden now my problem seems a little simpler because I am able to calculate something. So again, there's going to be times when you're going to want to expand, and that's what this is called, is expanding a log. Okay, so that's one thing that you can do. The other one, another type of property is the quotient property. So that's the product property because this is a product. And a product will expand to an addition problem. A quotient product is something that is being divided. So when you see a fraction, we know this bar means u divided by v. So this is a division, and we're going to convert that to a subtraction problem. So if, for example, I had, log base 2 of, let's say, 10 over 7, that's going to equal log base 2 of 10 minus log base 2 of 7. And so that, again, it might be helpful to us to solve problems down the road. We're going to do a bunch, okay? You might even get a problem that's a little bit more complex than that. Maybe in the quotient property, you're going to get something like log base 2 of, let's say, we can even use letters, right? Let's say A over B times C, BC. Well, that's going to be log base 2 of A minus log base 2 of B times C. But then all of a sudden you're like, oh, wow, this is a multiplication. I can expand this out further. I can do minus, and I want to group this because think of this, log base 2 of B plus log base 2 of C, because now I added it because it was a multiplication. Well, if I'm subtracting something that's being multiplied, I have to make sure that I'm going to either write it like this or that I distribute that minus, like log base 2 of A minus log base 2 of B minus log base 2 of C. And that would look like that if I distribute it. If it's a fill-in-the-blank test, I would be okay with you writing that, okay? If it's multiple choice, it might be in this form. They might have distributed, and you have to kind of remember that. But when we ask you to expand something, we want you to expand all of it. Like this is a division, so you turned it into subtraction. Since this is multiplication, we want you to go further and do that addition part. So again, that's another kind of cool feature, cool property, and we're going to go over lots of examples of it, okay? And then the last one is the power property. And that's what happens when you have a log where it's log base A of u, but that u is raised to an exponent. Well, that exponent can be moved to the front of the log and multiplied to the log. So I can take that n and move it, it goes here, and then notice there's the exponent here is just 1. There's nothing there. And again, that is sometimes very, very helpful. So something like that, again, an example might be, log base 2 of a to the second power, okay? Or let's call it b to the second power. Well, what that's going to be is I'm going to take this and move it to the front, and it's going to be 2 times log base 2 of b. And so, again, you're going to see in the examples many opportunities where you're going to want to do that, okay? And so let's do some examples here. So it says find the exact value of log, base 5 of 3 to the cube root of 5 equals x. That's a lot, right? So again, first thing I might want to do is solve this the traditional way, right? I know that this is log base 5 of 5 to the 1/3 power equals x. And for me, right, we already learned in a previous section that when the base and this match, you can cancel it, and 1/3 is x. And so yes, the answer to this problem is x is 1/3. Okay, exact, I would leave it as a fraction. However, let's see how I can incorporate some of the new skills to solve this. Because again, we want to kind of use all the different ways to solve something, right? I know, for example, that I could write this is still an old way, 5 to the x power equals the cube root of 5. 5 to the x equals 5 to the 1/3 power, so x must be 1/3. Again, I got the answer that way. And then what could I do with what I learned today? Well, let's see. If I did, again, this is log 5. This is 5 to the 1/3 power. We learned today the power property that power could move to the front, right? So this could equal 1/3 times log base 5 of 5. And you learned that log base 5 of 5 equals 1. So 1/3 times 1 is 1/3. And so notice, again, I got x is 1/3 every way I did this. And you want to be comfortable with every way to do these problems, because you're going to see sometimes there's going to be a way that's better, and you want to know them all so you can pick the better one at every time, okay? Here they're asking me to expand this problem. So notice it's log base 4 of 5 times 5 to the 3rd, or x to the 3rd power times y. So because all those are being multiplied together, I know that my first step in expanding this is going to be to turn it into addition. So log base 4 of 5 plus log base 4 of x cubed plus log base 4 of y, okay? And I'm almost done, except for the fact that when I look at this middle one, there's an exponent there. And we were taught how to change that as well. We were taught that that exponent moves to the front. So it's going to be 3 times log base 4 of x plus log base 4 of y. Okay, and so this would be the expanded answer for this problem. Okay, now what if, let's say, what if instead of, I don't know, let me see, what if instead of y, right, let's say that this last thing was a 4. Now, I know it's not, right, but let's just suppose, right? If I suppose that, my first term is going to be log base 4 of 5. I'm still going to have 3 log base 4 of x. But now I'm going to have log base 4 of 4, which you guys know equals 1. And so anytime one of the properties sneaks in here, we're going to want the answer to be like that. We're going to want the actual number. So it's not like if you just give us log base 4 of 4 and you don't change it to 1, it's going to be partially incorrect because we want you to simplify those whenever they come up, okay? But again, that wasn't the problem you were given, so I just wanted to throw it in there, okay? All right, so we come over to here, and we have a natural log problem. Same thing goes, right? It's the natural log of this fraction, which means it's a natural log of this division. So it's the natural log of the square root of 3x minus 5 minus the natural log of 7. Now, I'm going to simplify this further, okay? I know that this is the natural log of 3x minus 5 raised to the half power, because I know square root is half, okay? So what I'm really going to do is take this and move it to the front. So it's going to be half times the natural log of 3x minus 5 minus the natural log of 7. And now this is fully simplified. Or expanded, rather, not simplified, expanded. Okay? Okay, and then I go to number 6. And so, again, I start, and I'm just going to start with the most basic, which I see it's a division, so I'm going to do log base 3 of my numerator minus log base 3 of my denominator. Okay? Now I'm going to start to see, okay, my numerator is a product of two things, so I'm going to expand that out. Log base 3 of 4 plus log base 3 of x squared minus, and I know this one is log base 3 of y to the 1/2 power. Again, I see I have some exponents here that I'm going to have to clear out now. So it's going to be log base 3 of 4 plus 2, because I move it to the front, log base 3 of x minus, and then I move this one to the front, a half log base 3 of y. And this is the simplified, or I don't know why I say simplified. This is the fully expanded version of this original problem. And so again, expanding has a process. When it's a product, you're going to add them. When it is a quotient, you are going to subtract. And when it is a raised to a power, you're going to move the power to the front and multiply it. Now in this one, we're going to work backwards. We're going to go from a fully expanded version to a condensed version. In other words, we're going to put it back to the original condensed form, okay? So for this, what I do is I start with, notice this is a half times log of x plus 3 times log of x plus 1. So this times here and this times here, I know these go here as exponents. So I'm going to rewrite that. So I'm going to get log of x to the 1/2 power plus log of x plus 1 to the 3rd power. Now I can also write, I know x to the 1/2 power is log of the square root of x. That's fine too. But that would really, okay, so that's that. And then it's, so let me just leave this, log base 10 of x plus 1 cubed. And now I see that I'm adding them. So in reality, I know that this is the log of square root of x times x plus 1 cubed. And so that would be my final answer. I don't need you to multiply them or make it any more complex, but that would be a fine answer. So again, because this was multiplication, they have to be in the original. being multiplied against each other. Okay? I go to the next one, and I do the same thing. So first of all, I see this number here in the front, so I know that this is the natural log of x plus 2 squared minus the natural log of x. Okay? And then I know that it's a minus problem, so this is going to be the natural log of x plus 2 squared over x. Okay? And I think that this would be sufficient as your answer. I don't think you need to keep going and actually, do the top and do anything with it. That's fine. Like, you can leave it in that form. Okay? So again, when I see minus, I know it ultimately ends up having to be a division. Okay? Again, I look at this one and I see that this is 1/3 times all of that. So I could distribute the 1/3 first, right? I could do 1/3 log base 2 of x plus 1/3 log base 2 of x plus 1. However, I think the better way to do this is, since it's all grouped off, I could just raise it all to the 1/3 power. And that way I'm not really doing it to each individual one, but rather I'm doing it to the whole thing. So again, what I would do is I would, this is an addition problem, right? So I would do log base 2 of x times x plus 1. And again, I know that that's all to the 1/3 power. I could even write it as log base 2, and it'd be the cube root of x times x plus 1. And so again, that's another way of doing it, and I think I would rather do that, is to take this and make it the exponent in the front. I think it's just cleaner. So same goes for this one. It's 2 times all that, so I know everything is going to be, once I simplify it all, the whole thing is going to be squared. So again, I've got log base 10, right, or whatever, log of x plus 3, and it's a minus, so I know that's going to be a division. Okay, now within here I have, actually let me just clean up the inside first. I didn't see that. So let me do log of x plus 3 minus, and then this 2 log thing, I got to move the 2 over to there. So it's going to be log of x minus 2 squared. Okay, now this is all in brackets and it's all raised to the 2nd power. Because it's a subtraction, I know that this is log of x plus 3 over x minus 2 squared, right? Because that's what's in here. And then the whole thing is squared, so really it's this to the 2nd power, like that. So I feel like that's a little bit cleaner than doing, making each thing squared. I could have done, it would have been x plus 3 squared over x minus 2 to the 4th. If I wanted to do that, distribute that squared. But again, I don't really think that that's necessary. I think this is a fine answer, as is this one. And so again, when you're condensing, your whole goal is to get it down to one single log. And that's going to be the most beneficial, I think, for you.